Welcome. In this tutorial, I'm going to talk about Ethernet that's in Chapter 4, Section 4. I just like Section better than Chapter. However, the book says Chapter, Test Out says Chapter, so we're good with Chapter, even though I'm going to say Section. So what I want to do is just talk a little about Ethernet. This is taken from my last class, and I feel that it's got some relevant information. I will post the actual test out PowerPoint for you that comes directly from them as well. So let's start off with just plain Ethernet in here, and this is the actual architecture. We've already talked about bus topology, star topology. Bus topology is pretty much gone by the wayside except in older case scenarios. We already learned about star, and you can have both a physical and a logical. The physical really is exactly the layout of it, the connections and the physical items, and bus has both the physical and logical being the same. The star, the logical, is how data travels from one area to the other area in here. So again, we have copper wire, which is twisted pair UDP, SDP, fiber access, and media access over here. And the video shows a very great way of carrier sense, multiple access, and collision. Now, you really do not need to worry too much about that when you're using a switch. You only need to use that when you're working on a bus with a cable and everything travels directly through, or you're using a hub where it's going to broadcast in here. So basically what it does, it looks for traffic on the cable. If nothing is on it, it's going to send it. If something's on it, then it's going to wait till it's done. With bus technology, two people can send things at the same time and get a collision. With star topology and using switch, everything goes directly to the switch. So that gets taken care of internally. A collision, as explained, is when two data packets collide with each other. Corruption gets into the packet, and they have to be discarded in here. And then obviously a heavily tracked network is going to have a lot of collisions in there. Collisions will corrupt the data. There are tests on it each side to determine to make sure that the data packet sent is accurate and does not have any corruption in here. So basically what we're talking about on a bus is computer A sends a message to computer B, and it's the example is like a walkie-talkie. You can't really have two people talking at the same time. So if somebody's talking, you have to sit there and wait. If nobody's talking, then you can talk. So what happens if both A and B want to send at the same time? Well, if they both send, they're going to collide. So collision, the two messages are sent at the same time. Host sees garbage, not individual message, and it's going to send a jam signal. Both of them will, which will mean the computers are going to back off for a random time. So maybe one would be time A and one would be time A plus 1 millisecond. And what will happen is, as long as nothing is being on the wire being transmitted at that time, then it's going to transmit. So here is a flow chart of how things go. Okay, and again with a switch, you really don't need to worry about it because there should never be a collision. That's all going to take care of by the switch because everything has a direct connect to the switch and only that one segment. A collision domain is strictly the portion of the network where collisions occur. And then the collision domains differ from broadcast domain because broadcast domain is everybody on the network in here. Okay, half duplex and full text, again, a half duplex is used by hubs because it can only send data in one direction. Switches can send data in two different directions at the same time. So again, we have Ethernet is speed, transmission, media, data, distance, fiber optic, and multi-mode versus single mode, which we have talked about a bit. And then again, the 100 is the speed, and the T stands for twisted pair. And the media, T, unshielded twisted pair. The distance is 100 meters. That's the max that it can go on there. Don't confuse the 100 with the 100 base T. 1000 base T, CX can be 25 meters. And we'll talk about SONET at a different time. Connecting the nice two devices together. If they're directly connected, then you need a crossover cable because the send is one is going to be the transmit in the other. Two switches and a computer to through switch. The switch ports automatically perform switching when necessary. These are the newer switches. So you can actually use a straight cable or a crossover cable because the newer switches were going to sense which type of cable it has and will make the necessary adjustments. So there's a formula that you need to have an even amount will be a collision and not give it right. A uneven 1, 3, 5 number of turns is the right way to go. So the uplink ports are usually goes from one switch to a port on another switch, not the uplink port. And you'll see in the video that it does not provide switching. So you need to use a crossover cable if you're connecting a computer to an uplink port. And this is a little diagram of how it is. So you can see that the TX, which is transmit, must be to the receive, which is the RX. And then you can see uplinks, and you can see how they're connected. There. Router connections, just like a workstation, but it doesn't perform any switching. So you're going to use a straight through from computer to router. However, most routers will now do the auto sensing, so it will allow you to use whatever type of cable that you need. Obviously, if you're using the wrong cable, the data is not going to be accepted, and you're going to see some really nasty link lights. Look for yellow lights, and that's a big thing. If you have two switches, the crossover is performed. Use a straight through. Again, the rule, there must be an odd number of crossovers. Again, the newer switches all have auto sensing, and they won't do automatic switching. They will determine the type of cabling that's on each end and whether or not they need to perform the switch over here. So you can see broadcast domains and collision domains over here. A collision is totally different than the broadcast. The collision is only where the collision can occur. The broadcast is the entire network, because when you're sending a broadcast, it's going everywhere. So you can see the broadcast domain is everything over here and everything over here. But the collision domains are just strictly between the workstation and the switches. 10 base T, again, 10 represents the maximum output, 10 megabytes per second. That is pretty slow in today's standards. The T indicates a twisted pair, and base is baseline transmission. And the way it works is just two pairs of wires. Two are used for transmit, and two are used for receive, even though it has four pairs of wire. So again, follow the 543, 5 network segments, 4 repeating device, and 3 populated segments per maximum. Although things are changing, and with the more technology advancements that are occurring, you don't have to worry about that as much. Just remember, with the standard is 100 meters for twisted pair. If you use it, so it's roughly 325 feet. Here's 100 base T. That's called fast Ethernet. And don't confuse fast Ethernet with gigabit in here. So it's similar as 10 base T, only you can do 100 megabits per second, and it supports 3 network segments. 100 base TX is 100 megabytes, and full transmission doubles the effective bandwidth. So again, here's a 10 base T network. Now, you're not going to see hubs anymore. If you do, take the hub and put it on the nearest trash can, sell it on eBay for $1. Maybe somebody will buy it, and replace it with a switch. The 1000 base T is gigabit in there. Of course, 1000 represents 1000 megabits per second. And the same things, you need to have Cat 5 or higher for that. Really, you want to use Cat 5e or preferably Cat 6. That way, if you increase the speed, the Cat 6 is going to take care of it, where the Cat 5e really will not. 10G base T, 10 gigabits. Again, that's pretty fast. You need to have Cat 6 or higher. Obviously, the benefits is very fast and it's much cheaper than fiber optic. Also, easier to connect. Connecting fiber optic cables is very, very, very difficult. And again, you see some more slides of the same things in here. And again, fiber optic cable is the way to go. Then we have 1000G base SR and SW. So the videos itself will explain it in detail. Just remember the S is short, and when we get into the L, it's for long. The R works with LAN and fiber. W works with SONET. Multi-mode fiber, 850 nanometer signal transmission, and the maximum segment depends upon the fiber diameter. Again, more, here's long range in here, or long reach, if you prefer to call it. And then LR and LW is basically the same. Then you have ER and EW. E is extended reach, very, very long and very, very fast. You can go approximately 25 miles in there. This is a comparison of it from the optional book, so you can see how each one lines up and the speed and the distance. Another example of the LAN. Ethernet frames. Basically, we're using 802.2. 802.3 is Novell, Ethernet 2 and SNAC. The frame types are slightly different, but you see in the video exactly how they work in here. Again, the first part is called the preamble, and it alternates zeros and one that signify the frame start, ends in 1-1. The video explains that in great detail. Next is the MAC address of destination, and the next is the MAC address of source, and then data. And the last part of the frame is an algorithm that generates a number to do a check, a cyclic redundancy check. If it does not come out correctly, then we know that data has that. So now you have the common fields in here, which are in the video, so I'm not going to go over them one by one. You can take a look at that and the different types of standards that are in here. This is a power over Ethernet capable switch. That means you do not need to use power into an electrical outlet because it's going to get its power from the cables. Now the switch itself will need power, but the access points won't need it. That's normally used strictly for wireless. And again, these are PoE adapters. Also, it's used for phones. PoE adapters is a mini one that one will plug in to electrical and the other will plug in and give the power in here. So then you have the switching in here, circuit switching, packet switching, and multi-protocol label switching. You'll see that in the videos. Circuit switching, again, you'll see that in there. The uses live audio, video conferencing, phone calls. And packet switching is the most popular. So the packets travel any network path to the destination. It's going to find the fastest circuit available. And they don't really need to arrive in the same sequence. It can travel a different path. When you're going to Microsoft.com, it can go into 4 or 5 different directions and the packet gets assembled. So again, you have multi-protocol label switching in here. That's for IP and layer T WAN. Here are the advantages of it. Most important is the quality of service is really very, 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 very important. So you can see how the packet travels in here. Again, bus we're not going to spend a lot of time because it does really not exist, and I don't know of any place that does. So if you do find one, it's time to replace it. It has to have a terminator on each one. If it doesn't have a terminator, then electricity can bounce back and it can be causing data corruption in here. So you need to have that. It's called a signal bounce. Open and grounded is going to, one of them is going to have a ground on it, and that's to remove the electricity. This is a terminator. This is a ground. Notice it's a terminator that has a grounding slab that's normally screwed to the computer, back of the computer. This is the T-connector, so the wire will travel right through, and you'll have the T-connector gets connected directly to the computer. So you can see how on a bus, it's grounded on both sides. And the advantage to a bus is inexpensive. The disadvantage is it cannot meet the needs of today's networks. Star, again, you're going to have through a central device, a switch. So here you have a switch, and you have 3, 4, 5, 8 computers all hooked up to the same switch. And you can have up to 1,024 addressable logical network nodes. And the logical topology weighs that the data is transmitted between the nodes, not really worrying about the physical layout. So again, popular is Ethernet. Again, the benefits: flexible, various network media, great throughput, and is rather inexpensive. So that's it for this video. Hope that you have a wonderful day.